Okay, so this is my submission for ENME351 Lab 2. Here are my answers to the pre-lab questions. Okay, so this is my blink code. As you can see, the LED flashes every second. Just to run through the code line by line, under setup, I've initialized pin 13 as an output using pin mode. And then for my loop function, what I have looping is digital write 13 high. This sets pin 13 to be high and turns the LED on. And then delay 1000 makes the code wait for a second before digital write 13 low sets pin 13 to low and turns the LED off, waits for another second, and then that code just continues looping, so it turns on and off every second. Okay, and then this is my blink faster code. Now you can see the LED flashes every half a second instead of every second. So to run through the code, I first set delay length as an integer, and I set that to 500 milliseconds, which is 0.5 seconds, half a second. Under my setup function, I initialized pin 13 as an output, and then what I have looping is digital write 13 high, sets pin 13 to high, so it turns the LED on. Delay length holds that high output for half a second, since delay length is set to 500 milliseconds. And then digital write 13 low turns the LED off, holds that output for half a second, and then that code loops. So the LED continues flashing every half a second. And then still with the blink faster code, instead of 500 milliseconds, I'm going to change it to 10 milliseconds and upload that. And now the LED is flashing too fast for the human eye to detect, which makes sense because 10 milliseconds, that's 0.01 seconds, which means the LED is flashing 100 times every second. And then this is the LED for my fade code. That's what it looks like when I run it. To run through the code, I first have 3 integers, LED, brightness, and fade amount. Under my setup function, I declare the LED, which is hooked up to pin 9, as the output. And then under my loop function, analog write LED brightness initially sets pin 9 to a brightness of 0, so it starts off, and then the brightness changes for each run through the loop. So the integer fade amount increases the brightness of the LED incrementally by increasing the analog value of pin 9 by 5 every 30 milliseconds. Once the maximum duty cycle of 255 is reached, the fade amount switches signs and decreases to 0, where once it reaches 0, it switches signs again and increases back up to 255. And when that loops, that produces this fading effect. Additionally, if I increase the brightness duty cycle in the definition and in the if statement to 30 instead of 0 and upload that, then look at my LED, you notice that it doesn't completely turn off before reaching maximum brightness again, because it only decreases to a duty cycle of 30 instead of 0. And then this is my manual fade LED behavior. As you can see, it fades from low to high, flashes 1, 2, 3, 4 times, and then fades back from high to low. Here is my code for it. Right now I have the duty cycle of fade amount set to 20. If I change that to 10, the LED should fade much slower. So you can see it's taking longer to fade from low to high. It flashes 4 times, and then it takes longer to fade from high to low than it did when the duty cycle was 20. If I change the duty cycle to 30 and upload that, the LED fades much faster at this duty cycle than it did at 10 or 20. And for number 5, I created a code that will make my LED blink SOS in Morse code. So I'm going to upload that, and as you can see, the LED blinks 3 times fast, 3 times slow, and then 3 times fast again for SOS. And there's the code for that.